So, good evening, everyone. I am Dr. Satyabrata, MDDM clinical pharmacologist, and today I am going to discuss on forest plot. So, a forest plot is also known as blobogram. This is the graphical display of estimated results from a number of scientific studies addressing the same question along with the overall results, graphically representing a meta-analysis of the results of randomized control trial. Then why forest plot needed? So this is diagram showing on x-axis, that is the line of null effect, and it starts from the point 1, and the horizontal axis include the scale for statistic being displayed, that is odds ratio or relative risk in this case. So this is showing the different studies, and the result of this study is shown by the square, and the 95% of confidence interval of the result is shown in the figure, and also from point 1.0 to 0.20 it favors the treatment arm, and from 1.0 to 5 it favors the control. So this is another diagram showing the combining all the studies of forest plot. There are different studies, and the combining all the studies of forest plot is given by the diamond here, and we will learn about what are these diamonds and all of this in further slides. So this is the forest plot showing different papers, that is Gamsu 1989, and the year also written as 1889, and Carey 1994, and there are given the risk ratio 0.71 in case of Gamsu 1989, and also in other studies the risk ratio is mentioned here, and the square is the sample size, and the diamond is the overall study, subtotal overall study sample size. So this is in this picture showing in these two columns of figures, the first number in each column is the number of patients in the group which had the outcome, and the second number is the overall number of people in the group. Then this picture shows also all the same papers, and the forest plot. So this column basically just illustrates the lines of the forest plot in figures. You can go through different articles to learn more about this, and this row gives all the relevant information when all the studies are brought together into a single figure, that is denoted by diamond. And in this another thing is that heterogeneity of the papers. In this forest plot is showing total events 261 in treatment and 341 in control. Heterogeneity, that is chi-square is equal to 19.21, df degree of freedom 12, p-value 0.08, and I-square is 38%, and test for overall effect z is equal to 3.57, p is equal to 0.00035. You can go through different articles on meta-analysis to learn more about this heterogeneity. And this diagram shows study 1, study 2, study 3, study 4, study 5, study 6, and each study is represented by a line in the plot, and the event rates of each study are listed, and effect estimate and weight of each study are given here. And this is the forest plot. The risk ratio is given, and one arm is favors the experimental, another is favors the control. So you can go through different articles on meta-analysis to learn more about this. So this is also showing the diamond, which show the overall effect estimate. In case of a forest plot, diamond will show overall effect estimate, and the squares will, the size of the square will indicate the sample size of the studies. The bigger the square, the bigger will be the sample size of the studies, and the smaller the square, the smaller is the sample size of the studies. So to summarize what we have covered, each horizontal line on a forest plot represents an individual study with the result plotted as a box and the 95% confidence interval of the result displayed as the line. The implication of each study falling on one side of the vertical line or the other depends on the statistic being used. If the individual study crosses the vertical line, it means the null value lies within the 95% confidence interval. This implies the study result is in fact the null value, and therefore the study did not observe a statistically significant difference between the treatment and control groups. The diamond at the bottom of the forest plot shows the result when all the individual studies are combined together and averaged. The horizontal points of the diamond are the limits of the 95% confidence intervals and are subject to the same interpretation as any of the other individual studies on the plot. And the I-square statistic gives you an idea of the heterogeneity of the studies, that is, how consistent they are. If the I-square value is more than 50%, it might mean the studies are inconsistent due to a reason other than chance. This might make the conclusions you draw from the forest plot questionable. So coming to heterogeneity, differences between studies not due to chance, and it can be clinical, statistical. Clinical means differences in patients oblique study settings, study design oblique quality, interventions, outcomes, and judgments about clinical heterogeneity require no calculations. And in case statistical difference, individual trials have results that are not consistent with each other. Benefit versus harms, size of benefit or harm, and it is evaluated statistically. Then heterogeneity always present, but is it significant? To what extent does it affect conclusions of the meta-analysis? And it should be addressed. Test for its presence, quantify it, and investigate it. That we should address the heterogeneity in studies. Then testing for presence of heterogeneity. Chi-square test commonly used to find out the heterogeneity. And H0 means null hypothesis. If we will take null hypothesis, all studies are evaluating the same effect. High p-value suggests homogeneity. And low power, that is small numbers of included studies are having low power. Then quantifying heterogeneity, I-square, percentage of variation across studies that is due to heterogeneity and not due to chance. One rule of thumb, that is 0.25 as low heterogeneity, 0.5 as moderate, and 0.75 as high heterogeneity. So this is another forest plot showing different studies of forest plots for outcomes of death, pulmonary embolism, and major bleeding events in studies of low molecular weight versus unfractionated heparin prophylaxis. And you can it is not visible, so you can go through different articles on forest plot, on meta-analysis, so that you can learn more and more about forest plot. So that's all for today. Thank you very much. You can learn more and more from different articles, different papers on forest plot, and gain more knowledge on forest plot and meta analysis. So thank you very much. Jai Jagannath.